Okay, now we're looking at predicting products for double replacement reactions. We can recognize that these are all double replacement reactions when we look at the reactants and we see two compounds. These are going to be ionic compounds typically, and they're typically going to happen when we have two aqueous solutions that are being mixed together. Not all of these have the notations in the equations. That's what our AQ stands for here. This is an aqueous solution dissolved in water. So we're going to go ahead and do number 2 here. We know that double replacement reactions only take place if a precipitate, a gas, or water is formed. Water will be pretty obvious. One of the products will be water, HOH, which would be H2O. We're not going to have to worry about if it's a gas or not, but we do have to be able to determine if the products are precipitates. And a precipitate is going to be something that's insoluble in water. So the first thing I'm going to do after I recognize that it's a double replacement reaction, I'm going to write down the possible new equations, the possible new compounds that would be made in this reaction. And again, it's a double replacement reaction, which means that the two metals are going to be replacing each other. You could also look at it as the two nonmetals are replacing each other. It ends up being the same. But that's how we'll think of it. The two metals are going to replace each other. So I would just put those together. So the iron would now be with hydroxide, so Fe and OH. You'll notice I'm not really worried about charges and writing the formula correctly yet, because right now I just want to check those on my solubility chart to see if a precipitate is going to be formed. My other possible compound would be the combination of sodium and chlorine. All right, so now that I have my compounds that I'm looking up, I'm going to go to my solubility chart. So I'll go over to my reference section. First thing I'm going to look up is iron hydroxide. So over here on my left side is all of my metals, or my cations. Across the top are my nonmetals, or my anions, my negative ions. And I'm going to find iron. And I notice I have iron +2 and iron +3. So I got to figure out which one I have. Is it iron +2 charge or iron with a +3 charge? So if I look at my iron in FeCl3, there are 3 chlorine atoms in this compound. Each chlorine atom has a -1 charge. So if it has a -1 charge, the total negative charge would be -3. 3 times -1, which means that my iron has to have a +3 charge. So I'm going to check out Fe +3, and then, so I'll just draw that across here. And then hydroxide, which is right here. And where they meet, there is an I. I means that it is insoluble. That means it does not dissolve in water. So I know that I have a precipitate forming in this reaction. Just for the heck of it, I'm going to go ahead and look at NaCl. I think we should all know that sodium chloride does dissolve in water. But sodium, just to practice, is right here. And chlorine is right here. So as we see, that is soluble. But we only need to produce one precipitate in order for this reaction to take place. So now I know this reaction takes place, I'm going to go ahead and make sure that I write my formulas correctly. That's the important part of writing your products. You must write your formulas correctly. So iron, as we saw earlier, has a +3 charge. And I can go ahead and take a look at hydroxide in my polyatomic ion reference sheet and see that it has a -1 charge. So I need 1 iron and 3 hydroxides. Don't forget your parentheses. I need 3 hydroxides, not just 3 hydrogens. So it's Fe parentheses OH3. And then sodium has a +1 charge, and chlorine has a -1 charge. So when I head over here, now I can write those in nice. FeOH3 plus NaCl. So that is a double replacement reaction. The precipitate that was formed was the iron hydroxide. iron 3 hydroxide to be more specific. And those are my products. So I have successfully predicted the products of my double replacement reaction.